Hey there, everybody. For chapter 6 here, I just want to highlight that the content is not anything particularly new. We have been doing all this while pseudocode algorithms using sequence selection and repetition. The only real wrinkle here is that we've been doing them kind of exclusively without one another, right? So we have started off by using sequence. Then, after we've moved on past sequence, we moved on to selection. After selection, we moved on to repetition. And none of it was done through the chapter anyway. None of it is done to this point in a way where we are doing um, more than one kind of area at a time. So really chapters 1 through 5 have focused exclusively on one content area. And really all we're doing here with chapter 6 is saying, hey, look, we can focus on multiple content areas at one time. Something I do want to point out, I really kind of have qualms with the way that the outline for this chapter goes. It tells you that there are 8 solution algorithms, and then it kind of goes through the chapter summary and everything else. But there is no such thing as 8 solution algorithms. What they're telling you is here in 6.1 on page 73 of your text is through the next however many pages of the chapter, we are going to talk about 8 different solutions and develop their algorithms. So I really wish they'd have come up with something that was a little bit more sensical as far as the wording of that goes, because there is only a 6.1. It's everything in here is solution algorithms. So I hope that kind of makes sense and it doesn't drive you as crazy as it drives me. So just to kind of maybe remind everybody what's happening here. In developing a solution algorithm, the first thing we want to do is define the problem. It's important to, in very clear terms, um, settle on what kind of solution it is you're looking for. It is important that in very clear terms you settle on the nature of the problem it is that you are trying to solve. If you cannot do those things, if you leave those both open ended, what ends up happening is called scope creep. You think that you have a problem that's going to encompass, whatever, 3 months, let's call it. And over the course of an entirely longer time, so how about 2 years, you continue to investigate the problem. Well, why is it that your initial guess was 3 months and the final guess took you 2 years to go through? Well, that's what's known as scope creep. You kept expanding and expanding and expanding and expanding the scope of the problem that you were trying to solve, and that's a huge issue. So your first step is in ironclad terms to define the problem. Next is the control structures needed. This is what we do with the IPO chart or the defining diagram. I also refer to that oftentimes as DD. Once we get together, what some of the control structures we're going to need. We're going to need sequence, we're going to need selection, we're going to need repetition. Those 3 things. We can start to build our solution algorithm. The very last thing here is desk checking. Now, the astute reader will have noticed that throughout the text to this point, there have been desk checks, and I have been largely leaving them there for your investigation. What I will tell you is that with the relatively simple solutions it is that we're developing, I am happy if you spend the bulk of your time worrying about good, correct logic for that, as opposed to, how is it that you're going to desk check all of that stuff. Uh, for the time being, those problems, for the most part, are small enough that I think that you and I both can keep all of the disparate parts in our head and kind of manage what's going on. What I will tell you is, especially starting here and over the next 4 weeks, what I will do if there's any egregious logic error, one of your solution algorithms is just missing something that is, of tremendous importance to actually solving the problem. I will actually provide you with a little desk check to show just how far off that has potentially gone. But for the most part, that's nothing you really need to worry about. So without further ado, we'll investigate just a few more of the solution algorithms, but maybe not all 8.